There we go. Well, I guess let's get started. What questions do you have about the exam?
So I had a question. It was over just, I guess, the wording of the outline that you let out for us.
Uh-huh.
And maybe I'm just confused or forgot about it, but what do you mean by like correlation small, medium, or large? Could you refresh my memory on what that is again?
Yeah, so whenever you compute a Pearson correlation coefficient, right, sometimes the degree of relationship between the two variables is going to be small, sometimes it's medium, sometimes it's large, right? And so in the lecture video, or it might be easier just to look at the PowerPoint for the correlation module, it's going to describe the different cutoff levels for something being small, medium, or large. So like typically like a 0.3 correlation is going to be considered a medium correlation. Anything 0.3 and above. Does that answer your question?
Yeah, that's good. I just,
Okay.
like I said, I think it was just the wording. It was just for some reason throwing me off. So thank you.
No, yeah, good. Yeah, so, well, actually, I'll add on to this because I think that this is something that was confusing to some people. I got a couple questions in email and stuff, and some office hours meetings about it. So just a refresher, the correlation coefficient, it is conveying three independent pieces of information. The first piece of information it conveys is the direction, right? So if it's a negative correlation, that means as one goes up, the other goes down. It's also known as an inverse correlation. And then if it's positive, that means as one goes up, the other goes up, or as one goes down, the other goes down, right? And that's a direct or a positive correlation, right? And so that's the first component, right? The second component is the size of the correlation, right? It indicates, that's kind of what we're getting at here, that the strength, like is it small, medium, or large, right? And the closer the correlation coefficient is to 0, the weaker it is. And the closer it is to 1, the stronger it is. If you're ever getting a correlation that's greater than 1 or less than -1, something went wrong, right? It's bounded by 1, right? So the biggest correlation you can get is a 1. That's a perfect correlation. The third piece, and this is the piece that I think that there might be some confusion about, is the magnitude of the correlation. And the magnitude, what we're asking for there is the proportion of variance explained in one variable by the other, right? Now, this is also called the coefficient of determination. And the way you figure this out is you just square the R value, right? And I mean, just simply take your correlation coefficient and square it. And that tells you what proportion of variance in X explains Y, right? So how much are they related in terms of when one goes up, the other goes up, or when one goes up, the other goes down? How much are they related? So that's a marker of effect size. But I just wanted to explain that. So if you get a question that asks what proportion of variance is accounted for, you know that you just need to square R. Okay, I'll get off my soapbox on correlations. What other questions do you have?
So I do have another one about like in the wording, and one of the things was, what are the tails of distribution? Was on there, and I was just confused on what that's asking.
Which section is this under?
That was under the chapter 5. It says identify the tails of distribution, if I'm not mistaken.
So I think what it's kind of, yeah, that really isn't clear, is it? I think what it's kind of going with is kind of what the second bullet point is getting at. Understand the difference between, understand that the tails contain extreme values, right? And that as you get closer to the mean or the midpoint of the distribution, that's where most of the values are. So, we call it a normal distribution when it's normally distributed, but the type of distribution it is a density curve, right? And so I think it's important to be able to understand that the tails contain a lower density of people than, and it increases as you get towards the mean in a normal distribution.
Okay, thank you.
Okay, yeah. I'll
Yeah,
revise
that makes
that.
sense.
Okay. Would you like me to, I mean, it's on the study guide, but should we maybe start by like just fielding general questions about the exam itself and then move into like more content stuff? You want to try that? Like, did you have any questions just like about the nature of the exam?
Will it be timed, or do you have just all day to do it?
It is timed. It's timed. You know what? That's a great question. It is timed. Let me pull up BB Learn and just double check on the actual test itself what I have it timed as, or what the times are set for. It's totally doable. Okay. Almost there. Okay. 2 hours for each section. You get 2 hours for each section. And I think, an important thing also to highlight is that you have 2 attempts, right? So there's going to be the conceptual portion. You have 2 hours to do that. And if you don't like your first score, you can do a second attempt and you have 2 hours on that. Whichever one you get the highest score on is the grade. Same with the computational portion. So, I mean, if you were really, really, like, I know how much a lot of you are into this class and how much you enjoy taking statistics exams. And if you wanted to fill your day, there's a full 8 hours of statistics exams that you could do on Wednesday, if that makes sense.
Obviously. How many questions are in each section?
Okay, so that's a good question. So it's easier to answer that for the conceptual portion. There's a total of 40 multiple choice questions on the conceptual portion. On the computational, it's a little more challenging because technically there's 5 questions, but each question has multiple parts to it, right? So I might ask you, for example, to compute the sum of squares. And as part of that question, you might be asked to provide what the value of sum of x squared is, and then the value of sum of x squared, right? So there's 2 nuanced, slightly different computations, where one, you sum all the squared values of x, and the other, you sum all the values of X and then square the sum. So I might ask you to report those as part of one question, but there's really 5 kind of research scenarios that you'll be given, and you have to do the statistical test and the computations for it. Like you might have to compute correlation, you might have to do linear regression. Yeah, you'll definitely have to do z-scores.
And then any of these have to be done on SPS, or is it all based off of the like the homework assignments where we do it's ourselves?
So it's based like the homework assignments where you can do it like that. However, I'm not going to stop you from using SPSS. In my view, I don't do it by hand whenever I do statistical analyses. If you conceptually understand what's going on and you're able to do it in SPSS, go for it. However, if there's any disparity between what SPSS would spit out and what you would get by computing it by hand, there shouldn't be. But if there was, I would check your work by doing it by hand. You could actually, I think a good strategy would be to do the question by hand and then do it in SPSS and see if you're getting the same result. Does that make sense? It's going to be like the homework. Probably less difficult than the homework.
Okay, thank you.
Yeah. Good questions. Any other questions about the exam in general? Okay, sorry, I just opened the chat window. Maybe you could touch on the parts students miss the most on the exam. Okay, that's good. All right. I will just from past experience, I'm going to predict that this exam is going to have a bimodal distribution. Okay. The leftmost portion of the distribution are people who are finding maybe misunderstood some of the early stuff and have challenges doing that, and that misunderstanding can compound, right? And so there's going to a good proportion of people don't do as well as they would like. However, it's bimodal, right? So the other mode is the people who pretty much get it. I'm going to focus on that. I'm going to focus on the issues that people who tend to score highly tend to have. One is whenever doing z-score problems, not drawing out the normal curve and not appropriately identifying and shading in the region that you're trying to find the proportion for, right? So when you do those problems, you can do them real quick. Like if it's like how much above, how much below, it's easy to do those without drawing it out. And it's easy to make a habit of not drawing it out. But it will bite you if you do that. It's important to know the precise shaded region. So a common mistake will be like, say you had a normal distribution with a mean of 100 and a standard deviation of 10. And you ask, what proportion of people scored between 110 and 120? Right, so you're looking for a very specific shaded region, a band that's located above the mean. If it's not drawn out, it can be confusing at the end. You might do everything correctly and look up the correct proportions, but you might look up proportions for the incorrect region, or you might not know, oh, these need to be subtracted or added to come up with the final result. That's a common mistake. I think another very common and easy mistake to make is what I kind of mentioned before, like the distinction between the sum of all the x's and then squaring it, and confusing that with the sum of the squared values of x, right? When you're computing sum of squares, which as you see is involved in, it's very similar across correlation, across linear regression. And so sum of squares, those computations, I think oftentimes it's easy to flip things around. So just make sure that you understand how to do each one. And I would encourage you, one thing that I think you could do in advance of the exam that would dramatically reduce the time that you would need to take, you have to be careful, is if you know a little bit about how to use Excel, you could make a little Excel spreadsheet where you put in values and it will compute the sum of squares for you for those values, right? That way you don't have to do it by hand, right? And you'll know that if you put in questions from like the homework or things like that and test, you know you're coming up with the right answer, then you could use that on the exam. I think just in sum, the goal here is for you to be able to demonstrate that you understand how to compute given raw data, how to come up with the correct solution, and what that solution means. Right? The conceptual part is going to get that. The computational part will get the other half. Let me think of other challenging things. Let me just go through the study guide. One thing that I think people struggle with is way back at the beginning, being able to determine the difference between a like an ordinal interval and ratio variable or nominal ordinal interval ratio. So just, I can describe that. Nominal, you think name. It's just a number associated with a name. You can't do math on that. Ordinal, it's numbers that are in an order. But the problem with ordinal data is that it's kind of like order that people came in a race. First place, second place, third place. That's great, they're in order. You know that first place is first and second place is second. But you don't know if there's equal intervals between the units of those numbers. They're just in order. Another example would be like test grade. If we looked at the distribution of test grades in a class, we don't know how many points are between the units. If we said this person was first, this person was second, this person was third, we don't know how different their scores were, right? So that would be an ordinal variable. And then, so the next step, so each of these just convey a little bit more information. The next step is interval. In interval variables, you can do math on, right? Because there's equal intervals between units. The distance between 1 and 2 is the same distance as between 3 and 4, right? There's equal intervals between the numbers. And then, so the issue with interval data is that the value 0 doesn't actually mean zero. It doesn't mean the absence of something, right? So the common example here is temperature in Fahrenheit, right? 0 degrees does not mean there's no temperature. It means it's 0 degrees. It's arbitrary. It's an arbitrary 0 point, just made up. You can go to Celsius, right? And 0, like, and the spread from 0 is different, right? But the 0 point doesn't mean, for either Celsius or Fahrenheit, no temperature, right? It's just a particular temperature that we call 0 degrees. So the final thing, the ratio, is it, when it's a ratio variable, the 0 means 0. It means nothing, the lack of, the absence of, right? If I, for example, if I said that I walked 0 feet across the room, I didn't walk anywhere, right? There's no travel being done. If I ate 0 potato chips, I didn't eat anything, right? So that's the difference. And with absolute 0, yeah, you can do, that conveys the most information. And that's what we typically are dealing with. Typical numbers we're dealing with in day-to-day life are ratio, sometimes interval, but. Well, I went on a tangent there. Let me just go through and see if there's any other thing that people tend to no. I mean, performance on the homework is typically a good indicator of how you're going to do on the exam. If you can do sum of squares properly and make slight tweaks to do correlation and linear regression, you're in really, really good shape. The second thing is doing the z-score problems, right? Knowing which area to shade in. Those are the two, I think, most challenging aspects of the first exam that people have.
Can we have some of the supplementary materials open while we do it, like the areas under the normal curve?
Yeah. Open book, open everything, except open friends. Can't, obviously you can't give or receive help on this exam from any other person, right? It has to be your work, but the world is yours in terms of supplementing materials. Yeah, you're going to have, you're going to need your appendices to look at areas under the curve and stuff. All the equations that you're going to need for the exam, I have right up top. They're right there on the exam. So one caveat, and I mentioned this in the very first video of the semester, but I'll just highlight it again. One source of confusion that people face in this class is the temptation to use things like Wikipedia. Don't do that, right? It's not that Wikipedia is wrong. It's not. It's just that statistics, almost every field in the social sciences has statistics, right? Sociologists use statistics, psychologists use statistics, on and on and on and on. Statistics is used in the statistics department, right? But each one of these fields might have slightly different jargon. They might call A, like y equals mx plus b. Well, that's an algebra. Well, we're doing the same thing when we find the slope of a line in regression, right? Some people might have y equals ax plus b. Some people might have y equals bx plus a. And so that can get really confusing. So I wouldn't go outside of the content in this course in your textbook to seek, like to find equations or something like that. Are we going to need SPSS? You will not need SPSS. You should be able to do everything by hand. But again, you can use SPSS. Good question. So on the exam, it is going to tell you what, how to round, like what decimal point to round to. And I've administered this exam a couple times. Sometimes the questions change, but one thing I found is that I'll say round to this decimal point, but I leave a wider window around what's considered correct or incorrect. So if there's like some rounding error on the, fourth digit of a decimal, fourth, the thousandths place, or 10,000ths place, it's not going to get you the wrong answer. I'll be honest, I really don't care about your ability to round numbers. I don't care. So it's kind of made, so it will say what you should round to, like 2 decimal point precision, 4 decimal point precision. But if you, forget to round, or, you're not gonna lose out. If that makes sense. Good question, Karen. What other questions do you have? I will say it should, there's not any surprises on this exam. I mean, just like the videos, I did try to make it a little bit goofy in places. I am really trying to make this class as least painful as possible. I hope it's effective, It's, yeah, okay. It's that's a really good question. Why do formulas for calculating population and sample standard deviation, why are they different? Okay. Well, when we're computing a sample standard deviation, what we're trying to do is essentially estimate a population standard deviation, right? It's an estimate, right? And so instead of dividing by the square root of n, you divide by what's known as, and we'll go into this later. So like, in fact, I think for exam 2, we're going to actually go into that conceptual stuff in a little bit more detail. You divide by what's known as degrees of freedom, which is n minus 1. The square root of n minus 1. So all that does is it kind of is conservative, makes it more conservative in its estimate, if that makes sense. I hope it does. Okay. So yeah, I hope it's a really good question and indicates that you're really trying to wrap your mind around the conceptual differences with that. You will see as we when we start going into more commonly used statistical tests in the next sequence of modules, you'll see how that works more closely. Yeah. But I'd say for now, stem and leaf plots are not going to be on the exam. Were they listed on the exam review? They were. Yeah, they're not going to be on it.
This may be a silly question, but like for some reason I got it wrong in the last lab.
Okay.
How do you calculate how much variance is in something?
Oh, no. So the very first thing I was talking about, how this, like with correlation, the 3 pieces of information, that third piece is proportion of variance, right? So if you're trying to figure out what proportion of variance in X is explained by Y, you just square R.
And R's the Pearson R, right?
Yeah, that's right.
Okay,
You just,
okay.
like, so if you had a correlation like 0.3, you just square 0.3, and that tells you the proportion of variance in X explained by Y, or it's vice versa. Proportion of variance in Y explained by X goes both ways.
Okay, thank you.
Yeah, yeah.
There was one in the chapter 5 section that I didn't fully understand.
Okay.
It was describe the link between the area under the normal curve and the percentage of scores contained within the area.
Oh, okay. So what this is trying to do is encourage you to think, number one, it's trying to get you to kind of think through how proportions under the curve are distributed. So essentially, like, we know what is the total area under the curve? Anyone? Total area under the curve. One. Always one. Right? One is like 100% if it was in percentage, right? But we're in proportion, so it's 1. Every value is under the curve. 100% of all people are under the curve. Right? What is it's important to know the mean of a normal distribution splits a normal distribution in half, so it's symmetrical. And so, like, if you took the normal distribution and folded it, it would match up, right? And because of that, a perfectly normal distribution has an area of, or a proportion of 0.5 below the mean and 0.5 above the mean, right? So knowing that's important to know. Let's see. And so you can kind of leverage that information, understanding that the total area underneath it is 1, to find specific slices using the appendix, right? So if take, for example, if we had, we'll just use the example I had from before, right? You have a normal distribution with a mean of 100 and a standard deviation of 10, right? Just to make it easy, right? If I ask you to find the area between 110 and 120, and you drew that out, right? Well, you could start by saying, okay, I'm going to find the area from 120 to the mean, right? And then I'm going to find the area of 110 to the mean. And then I'm going to subtract 110, the area of 110 to the mean, from the area of 120 to the mean to get the specific band that you're looking for. But that's not the only way you can do it, right? Another way you can do it is you could say, okay, I'm going to look at the distance between 110 and the tail, and then 120 and the tail, and then subtract 120 to the tail from 110 to the tail, right? So what this is trying to point at is understand how the proportions work in the normal distribution, right? That it's all under 1, that it's 0.5 is the mean, as well as in a perfectly normal distribution, you know, there's a specific amount between 1 standard deviation and 0, between 2 standard deviations and 1 standard deviation, right? You know, you don't need to have those memorized, but you need to understand that that is how, that's why the normal distribution is so useful, is because when it's perfectly normal, we can really easily dice it apart and figure out proportions above, below, between, within, all of those questions. And why is that important? Who cares? Well, the reason that's important is because, well, in the real world, everything isn't always going to be perfectly normal. But we can determine how real world data deviates, how our sample data deviates from a perfectly normal distribution. And then we can still use, we can leverage our knowledge of those proportions under the distribution to make, we can understand how we deviate from that to make accurate predictions, even though our distribution isn't perfectly normal. And we will go into that in more detail before the second exam. But this is understanding how the normal curve works is really centrally important. Okay. So the question is, can you explain central tendency and variability? Okay. Well, I'll do my best, and you tell me if there's something a little, okay, no, that's good. The difference, what's the difference between central tendency and variability? Okay. When you have a distribution of scores, it's important to know the mean, right? Why is it important to know the mean? Well, if, say for example, yeah, because it's the average, right? The average, you know, here's one use case. If say you knew that the average score on the exam was an 85, okay? And I ask you, I want you to guess how this person scored, and you know nothing about this person. Well, the average is your best guess. That's where the most people fall, because it's a density curve, right? Most people fall around the average, right, in a normal distribution. And so finding the center piece of a distribution is tremendously valuable because it's your best guess in the absence of any other information. But and so, you know, the average is the most common, but there's, you know, others like the median and mode, right? The median is a measure of central tendency, and it just has a kind of a special use case. You would typically use the median to try to assess the center point of a distribution that contained outliers, for example. So, and I think I may have even used this example in the lecture, but like if we were all in a room together and we wanted to say, what's the average salary of all the people in the room? But Bill Gates and Elon Musk were in the room with us. Well, it would make us look like we're all billionaires. And that's certainly not, you can't use the mean because those outliers really influence the mean, right? So instead, in that case, when you have big outliers, you're going to use the median because it's immune to the influence of those outliers. With the mode, you're going to use the mode typically when you're looking at the most common practical application is when you're looking at nominal data, right? What is your ethnicity, right? And you have a bunch of items, right? The mode is going to be the kind of the measure. So on to the next point, right? So there's different ways to assess the center point of a distribution, but that doesn't convey all the information. We want to know what the spread is around that center point, right? So you could have a distribution that all the data is really tightly around the center point, or you could have a distribution where it's really spread out, and so what variance or variability is pointing to, it's also called dispersion, right? It's pointing to how wide versus narrow that distribution is. How do the points spread out about the mean or the median? Does that make sense? Okay, perfect. Good questions. Yeah, and please, if I'm not doing a good job explaining something, tell me. I'll try to explain it better. Some of this stuff is really tricky. You got a lot of moving parts, Any other questions? No, binomial distributions will not be on the exam.
Will there be percentile points on the exam? I was
No,
having
there
some
will
trouble
not.
computing that.
No, there will not. There will not be percentile points on the exam. I agree. In all honesty, I think that those percentile point questions are unnecessary. To be honest, I've taken a lot of statistics through grad school and stuff. I never learned percentile point calculation. The whole time. First time I learned about it was when I read the textbook. So some people think it's important. I'm a little biased, I guess. I just don't. I've never used it, right? And I mean, percentile point, you're attempting to find like percentile ranking, and percentile, this is going to sound so nerdy. Percentile rank is merely an ordinal measure of relative standing, and it's inferior to what you're doing with the z-score proportion above, proportion below, right? You can answer the same kind of question by looking at z-scores and using the appendix. So that's why I don't include them on the exam. In the future, I may even remove questions from the homework on those.
All right, makes sense. Thank you.
Mhm. What other questions do you have?
What do you think is like the best way that we can prepare for this? Like, should we rewatch lectures or go back through homework? Like, I know you don't provide like practice questions. So I just want to make sure that like, other than like getting the Excel sheet spread up or set up with sum of squares? Like otherwise, what do you think is the best way to prepare?
Well, I think the best way to prepare, if you know the areas that you struggle with, if you can identify those, you're in good shape. And I would just go back, watch the lecture videos. You can watch the lecture videos while you're taking the exam. Right? Like I would go back and focus on things that are like maybe some of the things that you've struggled with on the homework and the pre-lecture quizzes. I would go back and rewatch the lecture content. I'll probably do a lot better job in those videos explaining stuff with detail than I am here, right? I would do that. There are, I believe, let me check on BB Learn. I thought I had posted example problems.
Oh, you may have. I haven't looked yet. I thought when I looked at the study guide, I realized that there weren't any on there, but there may be some other in another place.
Yeah, I think under, I'm just want to double check because I don't want to misinform. Here. Yeah, so like I have at least under, I'm not going to go under each one, but I know in like the correlation module, there's supplementary materials that have example computational and example conceptual problems. And yeah. So yeah, you could do those. Those might be helpful. Oftentimes I even provide the key. Can I explain how to find the overall mean? Oh, I'll get to your question, Liz, as well. When you say overall mean, could you contextualize that for me? Like just how to compute a mean? I mean, what area? What? I'm honestly, I'm kind of confused. I know you're going somewhere, but I'm trying to figure out, are we in linear regression? Are we in correlation? In correlation? How to find the overall mean? Let me see if let me go back and see if I can figure out what you're. So while I'm looking this up, I'll go ahead and answer Liz's question. No, there's not going to be any Kolmogorov, Smirnov stuff. Okay. I gotta say, I'm not understanding the question. The one where you take multiple groups. Are you talking about like when you compute the Pearson correlation coefficient?
I know in one of the chapters when we were learning about like the central tendencies and stuff, it did bring up how to like find the overall mean, which is pretty much like the means of all the means of multiple groups.
And is this in the context of correlation? Okay. So you want to, the mean of the means? Yeah, it's not. Okay, wait a second. I think I know what you're talking about. Yeah. Are you talking about like if you have like computing making a weighted average? Okay, yeah, that's not going to be on the exam. So I'll tell you what, just for the sake of time, I'm happy if you want to come to my office hours. I can show you exactly how to do that. But yeah, that's not going to be on the exam. No, that's okay. Let's see, am I missing? Okay, I don't know if this is a new question, but is coefficient of determination just r squared? Yes. Yes, it is. So just trying to get a pulse, right? How do you feel? How prepared do you feel for this exam? If you had to guess. Like, okay. All right. What could I do? In your view, what could I do to improve the course? Just kind of seeking advice. Like how could I make this easier for you? A practice exam. I'll consider that. For now, I would say, I'm not going to have time to put something like that together before the exam and it'd be useful. But I would say go through and do the supplementary materials questions because those are going to cover the main things. I would say, if you're going to go back and watch videos and you're not confident in what your weaknesses are, I would say you definitely want to go back and look at sum of squares, the very basic sum of squares. Why, right? Why are we doing that? If you can understanding why we're using sum of squares, I think it's important. Understanding the real nitty gritty of the properties of the mean and the properties of the standard deviation. And then later on, understanding how those are at play in, for example, like least squares regression and simple linear regression, right? You can see how those are very similar. I'm emphasizing that because understanding those concepts at this point is going to pay huge dividends as we move forward in the course. And so really understand what the mean's telling you, understand what central tendency and variance are, understand why we're, when we're computing standard deviation, why we're squaring things, taking the square root of what we just squared, right? Why we do that. That's definitely something very good to wrap your mind around before the exam. Okay, well, you know what? So Liz, I think that's a good point. SPSS, it's really difficult to teach SPSS in a kind of an online format. Because oftentimes people run into technical issues and it's real simple if someone was there and saw it and could help you, right? That is one difficulty of doing this online. Fortunately, you are not required to do SPSS on this exam. There's technically not a lab component to this course. However, having a basic familiarity with SPSS is essential for you moving forward in psychology, right? You will use it in other classes. And so I tried to just drop the things in that I thought would be kind of important as you move forward, so that when you get into research methods and they expect you to use SPSS, you'll have a degree of familiarity with it, even though technically there's not a lab, right? So, but I don't test you on the exams on SPSS. Everything can be done by hand.
I do have another question. I'm kind of just scanning through my notes, and I noticed that standard deviation, if you square that, that also gives you the variance as well.
Oh, yes, right. So that's a good thing to notice, right? That the standard deviation, what's the square root of, or the square of the standard deviation? I might have said that backwards. The square root of the variance is the standard deviation. Am I saying this backwards? Now I'm like confusing it. But yeah, the variance is the standard deviation squared, right?
Yeah, so so there's two ways to get the variance in. That way, and then the square in R, or is that two different types of variance?
Two different things. No, that's good. You brought that up. Those are two different things.
Okay.
So variance. So R squared and finding the variance. It is the same variance, but I see what you're saying. That's a good thing to point out. But standard deviation, so you can kind of think of the correlation coefficient. I mean, just look at the equation, and it's similar to standard deviation, right? You're using sum of squares like formulas. So yes, to answer your question, sorry, I'm kind of out in left field here. To answer your question, yes, when you square the standard deviation, you get the variance. When you square root the variance, you get the standard deviation. Right? But that is a little different from the coefficient of determination, right? Where you're trying to find the variability in X explained by Y. Because the correlation coefficient, you can compute the variance on any variable, right? But what you're asking whenever you're asking what's the proportion of variance in X explained by Y is specific to the correlation coefficient, which incorporates additional information, like, for example, the sum of the cross products of X and Y. That's not in just the variable information alone. Does that make sense? Like it
Kind of, yeah, like I see where you're getting at. I just have to kind of look at examples to get a better understanding, but I know what you're saying.
It's the same thing, but you're doing it with a different variable. Like with the correlation coefficient, it means something slightly different, and it's computed different. Like the correlation formula is different from the standard deviation formula, but they're very close cousins, right?
Okay.
So it's awesome that you pointed that out, that if that you can square both of them, the same thing happens. But you can't, what I don't want you to do is look at the variance of X or look at the variance of Y in a correlation context.
Okay.
Yeah. Okay.
Okay. Thank you.
Uh-huh. What is the relationship between the strength of a correlation and the size of prediction error? Well, that's a good question. What would you think? So let's just think through it. I want you to visualize, right, what a weak correlation looks like. Weak correlation looks like a big cloud of dots, right? Whereas a strong correlation looks like dots that are kind of forming a linear pattern and are closer to one line. So whenever we're using least squares regression, right, or in correlation, right, but we really cover this in least squares regression. If you're trying to predict one variable from another variable, and you have a stronger correlation, there's less error in the prediction because those dots are closer to the line that you're fitting to it, right? So yeah, so the more that it's like spread out and noisy and you can't even hardly tell that you could draw a line through it, you're going to have a lot higher prediction error. But if it's a strong correlation and it's tight around the line, there's less prediction error, which means it's more useful. Yeah. Well, I'll tell you what. So I guess let's wrap it up here, and then keep in mind, I have office hours on tomorrow, right, from 12 to 1. Now I am going to cancel my office hours on Wednesday for the reason of I don't want people coming and asking for assistance on content that they're being tested on right then, if that makes sense. If you would like, I'd be happy to hold office hours on Thursday or Friday this week instead, but I'm not going to do it on the day of the exam. So if you have any other questions, please don't hesitate. Join the office hours from 12 to 1 tomorrow, Arizona time, and happy to help. I hope you're enjoying the class as much as possible. And thanks for showing up, guys. And good luck on the exam. There's no surprises. It should be a piece of cake. Good.
Thank you.
Thank you.